Hello everyone, welcome to my channel. So in our last video, we have discussed about the curling problem from Google Kickstart round G. So I have explained you with various examples how to calculate the scores. And today we will discuss mainly the code part, the pseudo code. Okay, so also I have explained the logic also in the previous video. You can go through that. And here I'll just concentrate only on the code. Okay. So first we have to consider the total radius. Okay, so when you want to check whether the stone is inside the circle, inside the home or not, you have to consider both home's radius as well as the stone radius, because if the stone is touching the circle, then it means that it's inside the circle, right? So we discussed in the last video. So that's why we are considering total radius, okay, to for creating that threshold or maybe the limit. Okay, and this is the syntax for that. In the input set, the first two integers are nothing but the radius of the stones and the home. So we are reading that and we are adding that, and we are using r total as our variable to calculate the limit. Okay. Then we have to calculate the distances. Okay, for each stone. Like after giving this radius, they will give you. The number of red stones followed by their coordinates, and then number of white stones followed by their coordinates. So you have to look through each of them, and then you have to read them X-ray and save their distances. So for that I'm using a square root function, and the square root of this x square plus y square, and this is nothing but I'm using the Pythagoras theorem here. Okay, and after this you have to find the minimum distance actually. So calculate the, because we have to find the stone which is closer to the center, right? We have to for red stone and yellow stone. So okay, so and after, apart from those stones, you have to ignore all the other stones, which is second minimum, third minimum. We have to ignore. We are considering only the first minimum distance. That's why we are considering this particular minimum distance. Okay, and this is the syntax for that. Here I'm using a try and except, because the list cannot be blank, but you can use if condition as well. Okay, and initially I'm having it as like an infinity, or you can use the limit set by the Google Kickstart problem. And now here comes the main logic. So here what you need to do is, like for redstone, okay, there are two sections. One is for redstone and one is for yellow stones. For redstone, look through the distances, and if the distance is less than or equal to the minimum distance of, like we have to calculate, one is limit is this one total radius, which is we got from here, and other limit is nothing but the other stones, which is yellow stones of minimum distance, and we should not be equal also. That's why I'm just reducing by 0.001. Okay, so if it is then less than that, then we have to then red points will get a point, right? So that's what I'm doing it over here, and same thing we have to do it for the yellow also. Okay, but here we have to consider minimum of the distance of a red stones. Okay, so minus 0.001, so that it's not even should not be equal also. That's why I'm considering this one. So you can change the, I mean, this particular logic as per your own wish, but this is like what I designed. So yeah, I'm adding here the points. But remember one thing: if this stone is very closer to center, and before that there's no other yellow stones, no, then obviously there won't be this condition will never satisfied. So in your output also, you may have observed that only either red or yellow will be having points. Okay, so both cannot have points. Yeah. So this is the code for that. Okay, so this is just finding a minimum distance and just adding that R wheel and this one, and that will be your output. So adding all these points together, this is your Python code, and I'm using a SQRT function from math live module. So it's the inbuilt module, so you can use this. So you can just copy this code in your Kickstarter. You'll get a for all test cases you'll get successful results. So let me know if you have any doubts. Okay. Have a nice day. Bye.